Hello pre-calc students, this is Mr. Lowell here doing standard 2.03 modeling. So first we're going to do the quick notes for modeling and then we're going to go through the practice problems. Often real life data does not perfectly match a specific function. We do our best to model the situation by using a regression analysis to find a function that best fits the data. The shape of the scatter plot can help us choose a model. Sketch the shapes of the functions below. This is the linear function, the general shape. An exponential function, a quadratic function, a cubic function, and a logistic function. Asymptotes on the bottom and the top. Since data does not perfectly fit any given function, our models will have some type of error. This error, the difference between the actual predicted value, is called the residual. The residual is the actual value minus the predicted value. To interpolate, this is to make a prediction within the range of a data set. To extrapolate, this makes a prediction outside of the range of a data set. The correlation coefficient of linear data tells us how linear the data is and is denoted by the letter R. The correlation coefficient is always going to be in between 0 and 1. The closer the absolute value is to 1, the more linear your data. Regressions can be run in the calculator. You can use StatEdit to enter the data, StatCalc to find a regression equation. To view the data, turn StatPlan on using the second y is equal and press Zoo9. The question asks for the goodness of fit of the correlation coefficient. You need to turn diagnostics on using the catalog, second 0. All right. That being said, let's go to the first problem. The data table below shows the average number of people that attend a water park per day in a given year. Which statement is true about the data? So our first step here is to enter the data in. So we're going to enter in the data. L1 has, so first we have 0 years after 2003, 2 years after 2003, by the way, it's 2005, 4 years after 2003, 6 years after 2003, 8 years after 2003, and 10 years after 2003. Moving to L2, the number of guests for 0 years is going to be 1,009. One, 2, 1, 6. 1381, 1609, 1854, and 2137. So our first step was StatEdit, and then enter data using the calculator. All right. So StatEdit and enter data. Then after that, we turn on StatPlot. So second stat plot, plot 1 on. So then we have second calc, which is stat plot. We turn stat plot on, and then we hit zoom 9. And so the data looks, this is what the data looks like. It looks linear. The data looks linear. So it's best modeled by a linear function. All right. And now we need to figure out what the average increase is per year. And what we can do is we can run a regression. So then to run our regression, we can hit stat and calc. Linear regression AX plus B. And our linear regression is going to be approximately equal to 111.17x plus 978.5. And so because each time x increases, because each time x increases, it has a coefficient of 111, the answer is going to be 111. So the answer choice is A. For number 2, owner plans to charge $12 for an entrance into the park in 2015. How much revenue would you expect the park to bring into the price? So first you need to expect 2015. That's going to be 12 years after 2003. 2003. So x equals 12. I'll show you a cool trick that you can do. You can go to stat, calc, linear regression. Oh, I guess it's not available on this calculator. Stat. Right. So then what you can do, I'll show it on maybe another time, but you can do 111.17 times 12 plus 978.5. So that's 111.2, which is approximately here, times 12 plus 978.5. So that's about equal to 2312 customers. It's approximately equal to 2312 customers times $12 per customer. So multiply that value by 12. That's $27,754, which is close enough to answer C, which is 27,750. So that times $12 per customer. So that's equal to $27,754, which is approximately just equal to 27,750. That's the best answer choice right there, C. Moving forward, what is the residual value for the model of the year 2009? Well, 2009 is 6 years after 2003. So the residual is actual minus predicted. So the predicted value would be 111.17 times 6 plus 978.5. So do 111.2 times 6 plus 978.5. So that's value is going to be, the predicted value is 1645.7. And the actual value is 1609, right here. 6 years after 2003, 1609. So that value is going to be 1609. And
good morning, Olympic family. This is Mr. Andrews. I just wanted to draw your attention to an email that I sent out yesterday that had some final exam testing updates for final exams that are going to be next week, January 14th through 18th. I sent out about 4 bullet points of information, so please draw your attention to that. Just remember that we are doing the NC test tutorial today for every teacher in every block. So make sure that you refer to my email with the directions on how to do that and the script to read that. Make sure you print off your rosters for every block and mark the students that have done it, and continue to do that until you get 100%, and I'll collect those during test training on Wednesday. If you have any questions, drop by my office or email me. I'll be glad to help you out. Have a great day.
all right. So the actual value is 1609, the predicted value is 1645.7. So that's subtracted, you get 36.7. The best answer is negative 36. Negative 36.7. The best answer is negative 36.5. All right. Data table below shows the population of a rabbit population on a farm. Which statement is true about the data? Well, it's actually pause. For problem number 4, you just enter in the data. So let's enter in the data. Stat, edit, change my numbers. 0, 1, 2, 3, 4, 5, 6, 7. Then I'll have 6, 9, 14, 22.
What is the rate?
35. 3. 79. 118. The first step is to use stat, edit, and we enter data. Then we make sure that StatBot is on. Zoom 9. Zoom 9. See that? Dot. It goes in that pattern. That is an exponential function.
We shouldn't have school period. It's a lie. It's just an adult day.
Guys, we have an exponential function here. All right. After you have your exponential function, we can know we have to do an exponential regression. So you go to stat, calc, exponential regression. Run the exponential regression. All right. And we go to stat, calc, exponential regression. All right, and then the exponential regression is going to be 5.99 times 1.538, so 1.54 to the x power. And so that means there's a 54% increase each year. So that's a 54% increase each year. Per year. Alright, so that's D, and that is the problem.
How many rabbits would you expect there to be on a farm after 1 year? So now that we have the equation, so we turn on our calculator. After we turn on the calculator, we are making a prediction. Is how much rabbits would you expect after 1 year? So remember, 1 year is 12 months. So 1 year is 12 months. So we'll have the equation 5.99 times 1.54 to the 12. 5.99 times 1.54 to the 12th power. That's going to be 1065.79, which approximately is equal to 1065.799, and the best answer, our best answer choice in this situation, going to be equal to 1052. All right. That's problem 5. For number 6. After how many months would you expect there to be 3,800 rabbits? So what we do for this problem is that we have a regression equation and we set it equal to 3,800. So regression equation is going to be 3,800 is going to be equal to 5.99 times 1.54 to the x. We're going to do some problems here. Do some algebra here. Divide each side by 5.99. So you're going to have the 5.9 will cancel out. And now 3,800 divided by 5.99 is going to be equal to 1.54 to the x. So log, when we convert from an exponential function to a logarithmic function, log base 1.54 of 3,800 over 5.99 is going to be equal to x. So I can take the logarithm of 3,800 divided by 5.99 divided by the logarithm of 1.54, and that will be equal to 14.944, which is approximately equal to 14.944, which means that 15 is the best answer choice. So C, 15. And then for problem 7, what type of model would best fit the data pictured? This, hopefully you can see that this looks like a quadratic. This looks like a quadratic, so this is a quadratic. So remember, this looks like a x squared polynomial. So that is the entire video. Hopefully have a great time.